Okay, it's 1:30. Let's go ahead and get started. First thing, hope you all had a good lunch and welcome. Next slide. So, just a reminder about the note well, essentially. Bottom bullet on this slide is remind you that about the note well, but also if you have a contribution to make, please tell us whether there is IPR associated with your contribution. Next slide is the actual note well. So if you're not able to follow the note well, please leave the room. Blue sheets have been started around. Note takers, we got one volunteer on the list. We'd like to have a second, just so that we have two pieces of noting to pull the minutes together from. Could I get one more volunteer, please? All you have to do is take notes and send the chair's email. Thank you, Barry. And we got a Jabber scribe, I think, on the list. Is that right?
No. We got just 1 minute.
Just no? Okay, so we also need a Jabber scribe. You get a reserved spot right next to the microphone. Can someone Jabber scribe, please? We're not going to start till we get one. Okay, thank you, Dan. I greatly appreciate that. You can't. Okay, he reneges. We probably won't ask our AD to do the Jabber scribing. Thank you, Robert. Okay, so turning to the agenda, we broke it into two parts. The first part has to do with things that are related to our charter, this being the first meeting of the working group. And we're going to try and go through it fairly rapidly, but you see we did allow a good block of time for discussion of the topic that will become the one standards track document that this group was chartered for. We asked the presenter to break that presentation into things that are follow on from the BOF and are just telling you how that input was handled, and open issues, which is where I would like to spend the bulk of the time. And then after we have gone through those two pieces, we'll see if the room has interest in adopting the resulting document as the starting point for the working group. Next slide. And the second thing is things that are not quite in charter, and if we will have the things that are in charter exceed their time and bump these things off in order if they take longer than intended. So hopefully we'll be expeditious and be able to do all of these, but if not, this is what you'll be losing. Okay. So this is where we are, the first official meeting of the working group, and we have not yet adopted any documents. May you do so today. And these are the big milestones from the charter. So basically, we need to get moving. Okay, next slide. And that's it, right? Okay, so let's move to the first presentation. Alex, I think you were the presenter, right? Okay, please stay in the pink box, and that clicker will allow you to advance the slides.
Hello, my name is Alexander Petrescu. I work, and I will present transmission of IP packets over IEEE 802.11 in mode outside the context of a basic service set. This is the draft name, the file name of the draft. I'm the speaker, my co-authors, with special thanks to a person that helped us a lot with the IEEE work and with the documents. My presentation has three main parts. I will introduce the progress since Berlin, because we have presented some draft in Berlin, and after Berlin we made some progress. Excuse me. Then I will list a few issues that are important at this time and that we would need to resolve today in this meeting. And finally, a number of solved issues that have been discussed extensively and that have found a convenient response in the draft. What happened since Berlin? Well, in Berlin or around Berlin, we actually had 4 drafts on the topic of running IPv6 over 802.11 OCB links. Each of these drafts addressed some particular aspect of this IP over foo concept. One of them described the multicast aspects, one of them described some security, one had some design considerations, and so on and so forth. So we proposed to merge the 4 drafts into one big document, and that is named after the first file name. And this is what has been published right before this IETF. But of course, when merging large amounts of text, you end up with a big document. And there is still much work needed. There is some editing work, some sections need to be moved around, and then there is some text that needs to be eliminated entirely, and then some clarification that is requested. But still there is some work on it. Among the comments from Berlin that we have addressed are the title. You will see the title. We have then improved the MTU text. Currently, we think the MTU discussion is finished, solved. We further improved the QS data header versus data header discussion, because in Berlin, we didn't know exactly how is distinction made. The distinction is made between those 2 headers. Right now, we know, because we learned in Berlin, there is a particular type subtype field that was suggested in Berlin. So we added it to the draft. But still, there is some clarification needed in this QS data header versus simply data header. And then we improved the multicast address mapping, into which we decided the prefix of MAC multicast addresses is going to be 0x333, not others. And finally, another important change that happened in the draft since Berlin is that we added in several places text about IPv4. There is a few industry requirements for IPv4 in some particular trials, and we thought it meaningful to add IPv4 text here. You will see which IPv4 text is added. On another hand, there was huge pushback on IPv4 in our discussions, including in the public discussion. And we would like to have a decision here. Maybe the decision will be relatively easy, but we will see. And we improved some figures. Well, figures are difficult to do, but they take time to make them better and suggestive. Let me now go to the situation of these solved issues. Okay. What we did since Berlin, the progress. This is currently the title: Transmission of IP packets over 802.11 in mode outside the context of a basic service set. That was suggested in Berlin. Sounds good. okay, but it's far from perfect in my opinion, in others' opinions as well. And there would be probably need of change. You would notice this IP instead of IPv4 or IPv6. We just say IP, but probably is not the right thing to do. And also note this transmission of IP packets in mode OCB, which looks, well, it looks a little bit clumsy in my reading. So maybe we'll have to change it, but it's maybe easy to choose a good title. Now let's go to the IPv4 proposed text. We refer now to RFC 894, IPv4 over Ethernet, RFC 826 ARP. We tell that the ether type is 0x0800 in case we want to transmit IPv4 datagrams instead of IPv6 datagrams. And we refer to the RFC that describes IPv4 link local addresses if we want to use IPv4 addressing. So there are some issues with this IPv4 text. And there are a number of arguments that have been made here. You see the arguments on the bottom of the slide. They are listed here, and the possible options are, these are the three possible options that we think about, and yeah. We need to solve this.
Yeah, Suresh Krishnan as AD. First thing is like the most important one, the chatter is IPv6, right? So I don't know, like it doesn't, so the way I see it, right, it doesn't have much text about IPv4, right? But the point is like we need some justification to put this in there, right? And I don't just see anything, right? Like either on the list. Like I think like maybe like you can talk to Tony and like probably come up with something. I think that would be good, like to put it on the group and then figure out how to do it. But I just don't see this as something that's just get arbitrarily added. I think Bob is going to say something.
Bob Moskowitz, AG Consulting. What I personally recommend on this is that this document be IPv6 only, that those who would like to have an IPv4 capability have a individual submission informational RFC of IPv4 and how it then maps and coordinates with this. You know, we don't specifically call IPv4 in here, but we don't exclude it so that the IPv4 is separate for that whatever trials or industry requirements wants IPv4, they can kind of like define their particular playground for that. And that may be a cleaner way in terms of the IETF organization to do that. That's my personal gut feeling on it.
Yeah, and Suresh again. So I don't have any problem people working on a draft in this working group, right? I just don't want it to see it in the IESG before like we have something that authorizes that thing. So as long as we get our original deliverables done, I'm fine with the group doing whatever at the next step, right? But I just don't want this to slow down. Like as I said, right, there's not much text in there, right? I don't see too many controversial things in there. But if something starts slowing things down for the main deliverable, it doesn't make sense to keep it in the document. Okay. Yep.
Eric Ving, Cisco. I'm pretty much in the line of Bob there. Oh, Eric Vinky. As far as I know, right, we're in 2016, and last time I checked, we were on the IETF, so that's a IPv6 only. To say the obvious, right?
Okay, so I'm hearing people say we shouldn't talk about this at all in this document. Is there anybody who wants to speak otherwise? Okay, so authors, please take the V4 discussion out of the document.
Noted. Okay. We'll take this out. So this issue is solved here. And So the next issue is the IPv4 link local addressing, but since we remove all IPv4 text from out of the document, then this is no more an issue. Now another issue that would need to be solved here is this MAC headers. We already introduced this in Berlin. People doing vehicular networks use two kinds of MAC headers up to now. One on the left and one on the right. The one on the left is preceded by an IEEE 802.11 data, which everybody is accustomed with when we work on Wi-Fi. And the one on the right, which is called QoS data. It's further, it's not shown here on the slide because of complex fields, but there are more QoS fields in this QoS data header, which are absent here, but are present, which are present here on the right, but absent on the left. So in Berlin, we said that there is a distinction between the two situations. That is in the value of the field type, subtype in the 802.11 data header. And that value is 0x0020, whereas in a QoS data header, that value is 0028. Okay, so the question is whether we should keep only this kind of transmitting IPv6 packets, or should we keep both the left side and the QoS data headers, another kind of transmitting IPv6 packets. There are implications of the decision. If we keep both kinds of headers, then the traffic class field of the IPv6 header, the flow label field also of the IPv6 header, and maybe other IPv6 fields that are used in diff-self contexts will apply here as well. And there is a draft at IETF that tells a little bit how to propose some mapping between the IP fields related to QoS and the 802.11 fields related to QoS. That draft is listed here, and there are guidelines for diff-self to 802.11 mapping. They do not consider vehicular communications, but then if we allow both of these two headers, both of these uses of 802.11 data and QoS data, then probably there will be need of additional work in the QoS field. Okay, so that's the implication.
Bob Moskowitz again. Are there any studies showing how the 802.11 QoS fields work in OCB? Do they even work? I mean, the debates and the issues we went in when we did this for an ESS were phenomenal. The fights around it and how it would even work inside an ESS were, I mean, only 11N was worse, in my opinion. Maybe 11R S also. But I would be very much interested whether this would even work in OCB in terms of the channel available in the rest of that. And so that if you want to do it in IPv6 and don't put it in the MAC. But I really like to see if somebody's done anything like this. Yeah. I would really like to see it.
Okay, so this is a question on the use. Okay, if I put it on the slide, is that there are some people who do use these QoS data headers,
but does it
for WSMP messages? And
but how does that work then in terms of channel use?
Yeah, that's another question. The study, the analysis of channel occupation, channel use, whether is it efficient or not efficient, or is it scaling to large vehicles or not, that's another question. But we've seen it in trials. Okay.
You know, in an ESS, it's managed, and how it works in terms of in an ESS, and it works, and we've seen some excellent things done with it.
Okay.
But it's like I kind of scratch my head how it would work in OCB. Well, I would like to see it. Point is something.
Okay, so it's put in OCB mode. The packet dumps that we've seen at a ITS website of the Department of Transportation in America. These packet dumps are used in trials and they work in OCB mode. Okay, but I cannot say here whether it's efficient use or is it bringing any benefit or not. Maybe yes, maybe no. I do not know. Okay.
And the other thing is, then it's only there, and as it leaves the OCB environment, the information is then not necessarily carried forward unless the infrastructure gateway then moves it into DiffServ. And this is then only in terms of the channel utilization by putting it into the header. Now, why are we doing it? Are we using it thus for channel utilization? Well, maybe I should take this offline so that you can. I see Russ going there now.
Yes.
Hello, Paul Zhang from SKKU. So the QoS data means L2.11 case, there is some header frame, there is a control field that indicate usually the DSRC L2.11 P case. I think that is close to the OCP model, right? So in that case, many people are working for the MAC layer, having this the control field telling four classes such as background traffic, best effort, video, and the audio. So if we can specify those class of traffic using IP version 6 traffic class field, the MAC layer using that field, and then try to channel access. Depending on the traffic priority, such as for the class of traffic, the random backup time is different, which means the channel access time depending on traffic priority. So I think my opinion is we can keep both of them depending on if upper layer traffic class in the IP version 6 telling some information, we can using the control field. Otherwise, we just using regular data frame. Okay, so we can, this is open some question, probably further we can work together. Okay, thank you.
Okay, so up to now, it seems that we should keep both of these manners of transporting IPv6 packets. Okay, the most usual, the most common, the most current, which is 802.11 data, and the QoS data, which may have some implications in writing some other documents. We will see. So that was my second issue. I will go now to, well, the fourth issue. This is a matter of, well, just a clarification. In a V2I topology, a vehicle is attached to a roadside unit and changes attachment to each new roadside unit that it encounters on the road. It does so by realizing IP handovers. And we have seen in the mobility work that IP handovers are improved if the router advertisement messages are very frequent. But very frequent router advertising messages means the channel will be very occupied. And we have a commenter said, and I agree, that there may be a trade-off between this very good IP handover performance and too much channel occupation, which may risk to lose important messages being transmitted. And currently, we think that in order to improve IP handover performance, we need frequent arrays, but we also agree that frequent arrays may occupy too much the channel. And is there any comment about this issue? If there is no comment, I think we will have to add some text that describes this trade-off, even though we will not add text that offers some mechanism or some new new solution for this problem, just a text that describes the trade-off, if this is okay. So that's what we will do with this issue. And this is again a textual clarification issue that I have to put here. In int area and in other working groups, so int area working group and other working groups, we have seen extensive discussion about the problems of multicast use in wireless environments like Wi-Fi. And the problems that have been described in these groups are even more important in OCB mode. Okay, so using multicast in OCB mode may create additional problems. And what we propose in our draft is not to describe these problems, not to describe solution or whatever, just to refer to existing drafts that describe the problems of multicast in Wi-Fi networks. One of the drafts is here, but there may be others.
Yeah, one comment is that maybe you should get in touch with the authors of this draft so they can include, if any particular issue related to OCB, because I think they are considering EO2.11 in general. I don't know if there is any particular issue of OCB, but maybe it's good that they also consider that there.
Yeah, good idea.
Okay, good idea. So I will talk to the authors of this draft and ask them what they think about these multicast issues in OCB mode. Thanks. And I think that ends the list of issues that I had on this draft. Now I have a number of issues that I consider solved that I could present. So this is solved, okay? It's I just present for the sake of presentation, because there was much private discussion about this MTU, okay? We decided to go with the MTU of size 1500, which is the same as on Ethernet or as on Wi-Fi, and we will use the minimum MTU of 1280. This is recommended by the IPv6 specification, which is currently RFC 2460. There was some discussion about this, why the minimal MTU should be 1280. How has this figure been decided? How has it landed on Earth? We have queried the IPv6 working group, and we learned that the 1280 figure comes from 1024 bits of payload and 256 bits of headers. This was a computation that was made several years ago, and then we will go with this computation at this time. Even though if you try in practice to set the MTU on a Linux machine, you could set a MTU as small as 250 bytes.
Suresh Krishnan, so is this history necessary? Like why it's 1280? The V6 document says 1280, so just take 1280, right?
The ULA?
The history, right? Like what happened 20 years ago? Like, is it important to put in here?
No.
Okay, good.
No, we will not.
So just put 1280 because 2460 says, right?
Is being updated, or yeah? Sorry.
Just because IPv6 spec says 1280, we do 1280. Okay.
Yeah. Okay. So just because, yeah. So another solved issue is the address mapping multicast. We will go. The question was what are the first two bytes of a multicast MAC address, and we will go with this figure 0x3333. This is the value that is specified at IETF, recognized at IANA. And other possibilities exist, but we will go with this one. This is what basic IPv6 specification does. This is what IANA knows, so this is what we are going to use, and this is going to be standard. There is a discussion about this LLC, okay? LLC is also a very old term. comes from IEEE, but right now it seems IEEE is advancing this LLC term into LLC being either LLC or LPD, you see. And there is an exception for the 5.9 gigahertz band, which is fortunate for us because 5.9 gigahertz is our frequency. And in this frequency, we can continue to use this LLC term. But in other frequency, maybe it's going to be different. So the decision is very simple for us. We will refer in our text to 802.11 OCB only once, and we will not talk about 802.11p again. And then this is some suggestion to IEEE that the relevant personnel IEEE takes into account. And we will make some suggestion to the Wireshark implementer about this name of the LLC or LPD. But this is a solved issue at this time. There is no worry about this, and IEEE is agreeing with it.
Channeling Dan Ramascanu, sorry. He suggests to refer the LLC change also to IEEE 802.1, not only to 802.11.
Makes sense, yeah. So we will channel this to appropriate IEEE persons. The interface ID discussion, we had many proposals about, actually we took the example of the interface ID definition from the RFC 2464, which is IPv6 over Ethernet. But since the time that RFC 2464 has been written, many things have been specified further into about the interface ID. For example, there are now security and privacy considerations. For the interface ID will not simply be derived from a MAC address, but there is no possibility and recommendation to derive the interface ID from a random number. And there is, in the past, there were those two U and G bits, universal and global local bits. I don't remember, 2 bits reserved in the interface ID that right now we consider them to be opaque, opaque. That means they will no longer have a particular significance. And there is an RFC about this in 6man, and we will refer to this RFC. We'll also have to align to the draft IETF 6man default IIDs. That is what is the default manner to generate an interface ID. So we consider it a solved issue because we will only refer to these documents. We will not add anything creative here about this. Yeah, further there is now, this relates to the security discussion, but I will defer to the security discussion. There is this use of multiple MAC addresses, multiple certificates in a car, predefined certificates, and all these matters, or how to generate randomly a MAC address prior to generating an interface ID. And we are aware of these discussions, but again, we will refer to these documents elsewhere instead of creating these new mechanisms here. So once again, sounds like an issue to be put outside of this document. The subnet structure, once again, subnet structure is a matter of more of a managed ad hoc network. So there are lots of documents at IETF that describe the subnet structure, and we will refer to these documents. For example, one of them is this draft Bacelli multi-hop wireless communications and then this RFC 5889 yeah. And finally, we have an appendix that tells how to use 802.11 OCB in order to transmit certificates on it, and security certificates. Once again, we consider this to be a good thing, but we will have to put it out of the document. Even if it is an appendix, it takes lots of place. And in order we want to have a short document and to be streamlined and to represent consensus of as many opinions as possible. in order to get as much deployment as possible. So that ends my presentation. Thank you to the group for helping making the decisions on the IPv4 and the other headers discussion. And yeah, that's about it.
Any questions for Alex? Okay. Surprised Bob hasn't taken his issue to the list yet.
I can take it.
Okay. Thank you. Next presentation then. I'm going to wait to the end of the standards discussion. Just to make sure people don't learn something from these. That's what I was thinking.
Hello, my name is Paul Jung from SKKU Sungkyuman University in South Korea. I'm talking about a survey on IP-based vehicular networking for intelligent transportation system, ITS. So the update from the last Berlin meeting. So the previous version draft is ITS, but nowadays our working group Ipwave is formed. So I submitted new draft name with following changes. Particularly the vehicular networking and security section is added. Also, each section we analyzed. So the key observations subsection is added to each section. Also, the editorial corrections are made. So this survey paper, the objective is we are providing general the ITS problem area will be our working group can think of it. So will be the basis some draft. So the assumption is, so yeah, we the current survey paper, most of the paper just based on the IEEE 11P, but our working group is based on 11 the OCB mode. But remember, these survey papers are based on 11P. So version 6 is considered for network layer protocol. Also, if we consider vehicle to infrastructure communication, roadside unit is infrastructure node, kind of access point connected to internet. And also traffic control center, this is a central road for the location management for the vehicle because the vehicle is moving around. So this is a kind of the home agent for vehicular area network. The categories for vehicular networking case, we have 5 categories. The first one is IP address configuration. The second one is the vehicular network architecture. Third one is the routing and also mobility management, security. So security is a new section. So yeah, IP address auto configuration case, you can see many people trying to take advantage of a structure of a road network using the vehicle case moving around. So in that case, the one about the vehicle will be the cluster header as the DHCP server. Or we are using the geographic information. So the per lane has some graphic information. So we can using we allow allocate subnet for unique, the prefix for the lane. Also the position of geographic area assigned to the subnet. So this is a geographic approach. So key observation is the vehicular area network case, the vehicle moving fast, the high speed mobility should be considered. And also neighbor discovery case, the IEEE wave, the 1609, the family suite, they don't recommend the IP version 6 neighbor discovery because of the overhead. So they are using 1907.3. They are trying using their own some address, some configuration, something like that. So we need to consider how to synchronize with their recommendation. The second one is the network architecture. So the VIP wave case, this providing beaker to infrastructure communication. Also consider multi-hop communication, one beaker, and the corresponding node will be the internet, the cloud server, something like that. So in that case, one hop, two hop away, the wireless access can be provided by the beaker area network. The second one is the IP version 6 operation in a wave case. I mentioned the 9.3 case, they don't recommend neighbor discovery because of the overhead of neighbor discovery. The second one is the IP version 6 link model case. We assume if the node with the same IP, the prefix, the node must be physically within the same communication lanes. However, the beaker case, you can see they making some multi-hop. So even though they are using the same subnet, they cannot reachable by one hop lanes. So in that case, we needed to providing some proxy-based or multi-hop routing should be supported. And the third one is, so the IP, non-IP multicast service is interconnected case we also consider. Also, the joint IP networking case, this paper proposing three kinds of IP, the beaker node. One is just the leaf beaker. The second one is, this is a relay node, extending the communication toward the internet beaker. Internet beaker means connected to internet. So we can say this is the mobile, the RSU connected to internet. And also some European project, the Plinet case, they providing some mobile agent based on mobile IP. So they try to providing beaker to infrastructure. The routing is proposed. Also the beaker, remember beaker case sometimes connected to internet when the roadside unit providing radio access to a moving vehicle. However, there is no such kind of beaker case. We need to consider delay tolerant. So this paper case, the L2, L3 case, there is some SIM layer, DTN bundle layer support DTN. So key observation is the unidirectional link exists. The roadside unit usually the installed traffic light, so the power transmission will be the stronger than beaker. So the communication range will be longer than regular beaker. So unidirectional link is may exist. Also, control plane must be separate from data plane for the mobility. Also, Alex mentioned for security case, the IP address interface information will be changed over time. So in that case, we need to think of lightweight DAD. Also consider also tunneling should be avoided. And the beaker do not have a home agent. So we need to think of how providing home network concept. Also the protocol-based mobility hidden to the beaker and the corresponding node. Also, we consider the IETF architecture for the efficient V2I communication. The third category is beaker network routing. So there are many tons of the routing protocol proposed. So in that case, the first step is IP address should be configured. So many people talking about DHCP, or we can extend the neighbor discovery based one. So some evaluation paper evaluate the proposal, European project how to C2C network. The project is based on geographic routing. So they showed the feasibility. And the key observation is IP address auto configuration should be manipulated for efficient networking, and network fragmentation should be considered because the beaker moving around, and then they can make some network segment. So that should be considered. Also, neighbor discovery also consider this network fragment. So link concept case I mentioned, even though they are using the same prefix, might be separated because of their distance. So in that case, we consider this one. So mobility management case, many people trying to tackle this issue using the DMM and the NEMO. So DMM case, hide the control, the tunneling address, the control management will be the big burden. So high mobility scenario case is not suitable. So we need to think of how to adapt the DMM approach for V2I case. So many people, NEMO, V2I. So our observation is the NEMO plus PMAP or PMAP for DMM. Many people are talking about this. So we need to think of it. If current our stage is not considered multi-hub mobility management, probably, next step case, we need to think of it. So also security case, this is a new section. So communication among the vehicles and the vehicle to infrastructure node case, we needed to set up the IPsec. So this paper is talking about IPsec. So the IKE case, they can make the session key using IKE version 2. Also, they can using the ESFP for the secure session. And the second one is also they mentioned the authentication, authorization, accounting also should be considered. So key observation is we consider a service also the handover issues. So this is a summarize. You can take a look. So next step is we want to moving forward enhance this draft for the basic document for ITS general problem statement and the problem statement draft. So also currently we just having academia papers. Our group willing to accept if you contribute the text. We willing to add you guys contributing authors. Please have an interest in our paper. So we also include the interest activity, also SDO activities. Welcome to your contribution. So any question or comment?
Eric Klein, can you go back to slide 9, I think? Or lightweight DAD. Rather than trying to modify protocol semantics too much, would another option be to just recommend that devices in these environments use optimistic addresses, an optimistic DAD, and that applications basically be forced to reckon with the fact that maybe somebody had their address and they didn't get the packets back and they need to take corrective action? Another approach we could follow?
Yeah, I think, we can take advantage of, some, you mentioned, so optimistic, some DAD. So, but we need to investigate more.
Right. We might not need protocol changes.
Okay, thank you,
Hi, Eric Ving, Cisco. Can you go back to slide 12, please?
Yes.
The third bullet there, application enable discovery should consider network fragmentation. It has been a well-known source of attacks. NDP packets should not and never be fragmented because they bypass filters.
Oh, this one is not packet fragmentation, just network fragmentation. So which means that the vehicle add-on network can.
So discussion, just to clarify, I think this means partitioning when he says fragmentation. So the network like partitioning and healing.
Not packet.
The network gets split, like so that it becomes into two islands, like that are not reachable.
Okay. Sorry for that. So made the confusion.
And on slide 7.
7. Okay.
I don't think it was 7, but at some point of time you were talking about SLAG and so on. There are concepts to reduce the multicast in an, let's say, Wi-Fi environment, which is basically allocating a /64 per node. So basically then you don't do that or NDP anymore on this one. So there are other solutions that are explored in other groups.
Oh, you are saying the multicast, right?
Sorry?
So are you talking about the multicast for?
Yeah, basically to reduce the ND chat and multicast effect. Because if you do a /64 per endpoints, then you don't do ND anymore.
Okay.
There are a couple of solutions in this space, basically.
Okay, so multicast also, yeah, we need to take, yeah, in the case, yeah, further. Thank you, yeah.
This is W from Alibaba Group. From the content of the draft, I think the most content comes from the academic research. So I think in the charter, the purpose of the draft is to, describe state of art of the vehicle communications industry. So I'm not sure this is the right direction of.
So yeah, I think so. I mentioned here. So we include industry activities such as GM, Toyota, Honda, BMW. They are working for the vehicle error network research much. So also standard case, the edge case, ISO. They are working for this area. So we include next version.
Yeah, but I don't see the content in the current.
The current case, this is the next version case. So that's why I actually welcome to new people working for this.
Yeah, and also 3GPP, they're also working on LTE V2V.
Okay, sure. Yeah,
I think that should be also in
so
scope.
yeah. Okay, sure. Yeah. Okay, thank you. Yeah, good comment.
Okay. I'm Minpeng from China Mobile, and the page 3, can you?
Oh, which page?
Page 3.
3. Okay. So, yeah.
I see there is the assumption of the vehicular network that the roadside unit is connected to the internet as an access point for vehicles.
Mm-hmm.
As Dapeng said, there is maybe another way to make the vehicle to connect to the network directly. So I think that the roadside unit is a kind of way to make the vehicle connect to the network, but it's not the only way.
Right. So we can also consider the 4G LTE.
Yeah.
So it will be used as some control channel telling location on direction. So yeah, that's a good comment. Yeah, we can add in. Yeah. So other unit. Yeah. Okay. Technology can be used. Okay. Thank you. Yeah. So
one comment from my side. I think that you want to continue working on this as a potential candidate in the future for one of the charter items.
Right, sure. It's general, the problem area.
I think one point that is not yet covered as far as I mean, the quick look I took to the draft is the use cases. Mm-hmm. One of the points is that to cover use cases of IPv6 over on vehicular. Okay. So I think that's something that needs to be covered as well.
Okay, so use cases. Okay, sure.
And that for that is really necessary to talk to the industry guys as well. I mean, to cover those.
Okay, sure. Yeah, that's a good point. Okay.
Thank you.
Okay, Alex.
Well, excuse me. So I take this remark from Carlos, but there are some industry guys in the room that would like to contribute these use cases.
Okay, sure. Okay, okay sure.
So you really need to.
Okay, sure. Yeah, somebody interested in use cases. Yeah, welcome. Yeah.
Seljan from SKKU. Question to Carlos: that what do you mean that this is survey draft? Why such use cases should be included in there?
Because it's in the charter. There is one document, informational document, that is supposed to be surveying efforts on IPv6 and vehicular and use cases. So use cases.
You mean a survey about use cases, right?
Use cases will be part of that informational document that we will provide. So, and as I think that draft doesn't cover, so I'm just suggesting that this should be addressed, included.
I mean, not the putting the use cases for vehicular networks, just a survey about use cases, right?
Yeah. Survey. Yeah, sure.
Say like just to this is Suresh again. The point was like I think I sent you the IESG statement like about the support documents. So the idea is to minimize the number of support documents like working groups produces. So like we don't want like a separate problem statement, a separate requirements, a framework, and a use case, set of documents. So I think it'll be good if like all the support stuff gets bunched together into like a single document. Thank you.
Sure. Okay, can we move forward? Next, slide. So the problem statement for the vehicular to infrastructure networking, this has update from the last Berlin meeting. So the service discovery section is added, and also we get rid of the site local address. We just focus on ULA, unique local IP version 6 unique unicast addresses. Also, many sections are improved with the editorial corrections. So objective of this draft is to specify the problem statement for the vehicle to common infrastructure networking. Also, assumption is the L2.11p or OCP most used for the MAC protocol. Also, IP version 6 is used as a network layer protocol. Road side unit is connected to internet as access point. Also, might be we can include the LTE also. So this draft is a focus on networking issue, one-up communication between RSU and the beakers. Also, internet networking between beakers, internal network, and also the RSU's internal network. So this figure shows the network configuration. So this is the RSU. This is the access point for the internet for beakers. The beaker moving around like this. So it connected to the internet. We can say a beaker cloud. So it has a traffic control center, means a kind of the central node to manage the mobility of the beakers. Keep track of the mobility information. So this figure shows, I mentioned, this is a beaker. Inside the beaker, we have the multi-hub network, such as nowadays the beaker itself, the ECU and the sensors, and also user, the passenger, the driver can connected to beaker internal network. Also, the RSU also providing many services, navigation, traffic, the advertisement, accident avoidance. Many services can be provided using this internal network. So the issue is IP version 6 address case. So we can using some local address or global address. If the beaker connected to the internet case, probably global address used. Otherwise, we can use a unique address can be used. And the neighbor discovery and address auto configuration should be considered, and also the DNS naming also should be considered. IP mobility case, if the beaker moving to another RSU coverage, mobility should be considered handover, something like that. And service discovery. So the service discovery is very important because the vehicular, the area network case, we providing some navigation service or some accident notification service, many kinds of service can be used. So the first question is how to register that kind of service into RSU and the beaker, and how can the RSU beaker can share that service information. So this figure shows the devices in beaker devices register into the beaker, and then it can communicate with the other car, and then they exchange data to get some service. So you can see inside the beaker, inside the RSU, so the beaker services register some system, and then they can communicate using. So this figure just to show one example. Extended neighbor discovery can be deliver the network information and the service information. So next step for this draft is the merge. Alex provided the V2V draft. We try to put together and then make the problem statement, and the security consideration also enhanced. So synchronization with the STO terminology will be merged this draft. We welcome to comment and your feedback. Thank you.
Moskowitz again. Any communication from inside the vehicle and various control and use the cameras and so forth to outside is such a big security liability that don't even go down that way. At most, and at least in conversations with 3 OEMs that I've had, it will be 1 or 2 components which will be talking to the world. They'll be doing all the collecting of information and communicating what is appropriate outside. So when you're showing like the dash camera and the rest of it, the connection will not necessarily be direct to the dash camera, but maybe to the to another system which the dash camera is streaming the information to. You really have to look at it in that way. The security risks are absolutely phenomenal as we go down this path, and try to sink in with our thoughts in the industry as we're trying to get out of the environment where somebody outside can bleed your brakes while you're going down the freeway at 70 miles an hour, where somebody can change what your camera's feeding into the control system so accidents happen, the rest of it. Please do that. That's the first thing. The second thing is that in terms of certificates, there are a couple different things which are going in terms of component certificates, much different than the DSRC radio certificates, and how that may work. But that's more components inside vehicles. To the larger world, we are thinking some of that, but there is not going to be an anonymity there because there is a need of OEM control of their vehicles and so forth. So maybe we can have more discussions on that. But I am really disturbed when people are thinking about that they're going to be communicating to components inside the vehicle. I cannot guarantee any vehicle security if you allow that. Thank you.
Yeah, that's good comment. So you can see some desk camera or navigator application case, the outside, some server can talk to each other, but the ECU case, so the engine or braking system, if exposed to the hacker, it will be a very big some accident, right? So we at the moment we try to focus on some not related to controllable vehicle, just some other separated the devices can be connected to outside. So we can narrow down some application for that. So, but I think still it is useful use cases, I believe. Okay. So this work is open to you, so anybody can contribute, and we can add you the contributor authors. Also welcome your contribution. Thank you.
Eric Flanagan. I thought in your previous presentation that you just gave, there was something about IPv6 ND is not recommended to be used. And here's some options that are the options being defined. I'm wondering how we reconcile these defining of new options when we're recommending not to use the protocol.
Okay, that recommendation from IEEE, the 1609, the family, the members, not our member. So they just recommend try to make some 1609.3. They are providing some different way deliver gateway address and the subnet information, but still I believe some neighbor discovery also useful. So that is their opinion, my opinion, or other.
So we're doing something different.
Yeah, different. Yeah.
And we don't expect to have to worry about interoperation.
Yeah,
that's correct. Okay.
Yeah.
But I thought multicast and all that stuff was still considered expensive.
Multicast.
Right. This document that specifies the VPI and the SPI options talks about neighbors multicasting via including it in their NS, multicasting their own NS with all their services and stuff like that.
Oh, DNS.
And other neighbors hearing about it and responding.
Okay. So I think you can see the naming case. MDNS maybe one option. Otherwise, the other option is we can use the unicast DNS naming. So we try to reduce multicast cost.
My question was not about DNS, but it was about the use of multicast.
Oh,
I thought multicast itself was considered.
Okay, so we
expensive.
need to consider multicast also. Okay. Sure. Yeah. Okay.
I'm sorry. On these links, my impression from things in previous presentations was that multicast and I assume also broadcast are expensive.
Expensive, right?
For energy reasons or who knows what. And yet we're having nodes multicast all the time, their neighbor solicitations continuously. Is that not going to be expensive in terms of energy?
So I think the vehicular case probably consider density of a vehicle, so we can adjust the advertisement. So we try to reduce the multicast cost.
In this environment, the IEEE 1609 stuff is broadcast. A lot of those safety messages are broadcast messages, so probably where that
Not an issue.
is coming.
So the RSUs are powered and the cars have 12-volt batteries or whatever, and
Exactly.
so everybody's
Right.
got enough energy.
You're not worried about the same battery life issues you are with your cell phone, for example.
Okay, so then, so the multicast and broadcast are not particularly expensive then,
They're
Yeah.
being used all over the place.
in that sense. All right, sorry. So I was my misunderstanding then.
Yes, the DSRC components are not cheap because of their signing every wave message and everything else. They have a lot of ump into them and a lot of cost in them as a result. Inside the vehicle, many of the OEMs are not going to do V6. Many of them, again, you have to distinguish between the safety network segments versus the non-safety infotainment. On the safety networks, they are talking literally locking it down, fixed IP addresses, no DNS, and the rest. But on the infotainment side, this is where you'll be plugging your only place where the customer will allow be plugging anything in. So yes, they are talking about DHCP or RA appropriately on that network. And what may occur over there. You may want to make that distinction clear.
Okay, sure.
Between the differences on there, so you don't drag people into thinking again, oh, I can get to the safety components. No, that is totally segmented off and talk instead about the other networks where, yes, there are needs there, and it may help clarification.
Okay, so I will separate the two networks, okay? Okay, thank you.
So Bob, I think you misspoke.
And a comment.
Or maybe I took what you said in a broader context than you meant it. The IP address of the radio is changing.
No.
Yeah. In the 1609 spec it is.
I'm working with two OEMs and talking with the third one where the brake unit in every single car for a particular model will have the same IP address. Fixed at installation time and so
Sure, for the inside the car devices, not the radio.
Oh, no.
That's
right.
what I said.
Okay, I misheard you. I didn't hear you say radio. You're absolutely,
Radio.
yes, absolutely correct. Yes, but
Okay.
that's the
Thank you.
DSRC is not on the safety network.
DSRC absolutely is on the safety network.
It's bridged to the safety network.
Safety messages are transmitted in the DSRC frequencies.
From here, I go into NDA, so I have to shut up.
Okay, so if you have a comment or question, you can send your opinion to our mailing list, okay? Thank you.
Thank you.
So where are the blue sheets, and has everyone in the room signed them? If you have the blue sheet, hold it up so someone who hasn't signed it can come get it.
Wait until the end for this.
Are we moving to the, yep. I'm sorry, could you hold on a second? Now that we have finished the presentations related to the charter items, I'd like to see whether the group thinks any of these are ready for adoption by the working group as the starting point for the deliverables of the working group. So the first one that was presented by Alex had an intent to become the standards track deliverable on how to use IPv6 over 802.11 OCB. Does anyone want to speak to whether they think that's ready or not? If not, then I will like to take a hum. It'll be hum now if you think the working group should adopt it, and hum now if you think it should not. So the first one, hum now if you think the working group should adopt that document as the starting point for that standards track deliverable. Hum now if you think we're not ready to adopt any document. Okay, so it was much stronger from the front of the room anyway. The to adopt. but there were still people who think it's not ready. I'll take that to the list with the recommendation that the people in the room thought we should adopt it. Okay. Second, we had discussion of the information document. This week, we got the guidance from the ISG that they want many fewer informational documents. Suresh already spoke to that, so I think we should hold off on adopting anything in that area till we can coalesce those into one document. Does anyone think that's the wrong thing to do? Okay, thank you for reminding me. Sure.
This is Pete Resnick. There were a couple of people who said that the first document was not ready to be adopted, and I'm curious if any of those folks would like to explain why.
I think that's a good call. We should have put a microphone over in the aisle. Or Bob should have sat in the middle.
If we adopt the changes which were discussed today, then I think it's ready.
Okay. I'm sorry. I made the assumption that since it would be reposted as draft IETF Ipwave, blah, 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 that in doing the update, those would be incorporated.
Right. You incorporate what he said and the rest of it, that then.
Okay. Sorry that that wasn't made clear in my remarks, but that's my working assumption. And we'll have time to direct the editor. Yes.
So Dan Ramascanu says changes about title IPv4, title and IPv4. So.
Oh, changes about, he wants it to say IPv6. Is that what he's saying?
I'm waiting for him to type more. He says take out IPv4.
No, we already said that. We directed the editor and are confirming it on the list.
One other thing about the title can just say 8211 OCB, and in the terminology, OCB defined. We don't have to spell that out in the title.
That will be a discussion with the RFC editor, I think. But I think it reads better that way. I agree with you. Okay, thank you.
This is Jong-Young Lee. Today I'm trying to speak about security and privacy issues in Ipwave. Rather than propose a specific solution, I'm trying to give some issues. Then we can discuss these issues in the mailing list. So we have some background. Actually, the safety messages are not transmitted in IP version 6 packet. So, for example, basic safety message and cooperative awareness messages are sent in non-IP packet. And also, so in our working group, we are mostly consider IP version 6 packet transmission over 11 OCB mode, and also IP version 6 communication for V2I and V2V communication. And from the perspective of security and privacy, if we look at the 11 OCB mode, it has some specific things, like because this OCB mode does not have message proof and authentication and authorization and authentication and association procedure. So because of this reason, we cannot have authentication and message encryption, and also we don't have a privacy protection. However, from the IEEE and ETH European standard, those organizations have defined some security and privacy mechanisms. So IEEE and ETH, they defined some security mechanisms, and they have some specific property. The first one is they have defined to use asymmetric cryptography and certificate. For example, ECDSA can be used because it is more lighter than RSA. And then second, they are trying to use a set of pseudonym. A pseudonym is a temporary certificate that does not contain any identifier information. This is because of to support location privacy. Also, one pseudonym it is recommended to use a very short time. And the third, they recommend to use MAC address randomization. It is also because of to support location privacy. And the last, they have some scheme to frequently change pseudonym and MAC address. It is also because of location privacy support. So in our working group, we have some assumption. The big assumption is that IP version 6 run of IEEE OCB mode, which means that security and privacy mechanism has been developed by IEEE and HE. Those mechanisms must be used together. And for example, MAC address is changed and it is not controlled by network layer. It is controlled by a security entity defined in IEEE or HE. So just let's talk about some security and privacy issues from the perspective of our working group, Ipwave. The first one is MAC address change. If the MAC address change, it means it causes IP version 6 address change. And IP version 6 address change, it means if there is a communication session established with that IP address, the session is disconnected. Also, it impacts NDP protocol and DAD protocol, and if we use CGA or send protocol, we also have some impact on that. And also, binding update message should be resent because we changed the IP address. So here's just some figure. Even
2 minutes. Okay.
Even if we have even if the vehicle didn't change anyway, he just stay in the same area. But if his MAC address change, it means IP address change. So he needed to do some message signaling regarding NDP protocol. And once he configure his IP address, he also registers his new address to somewhere like home agent. There are a lot of message signaling required. And also pseudonym change also required some key leaking problem. So there are some performance decrement. And at the IETF level, we have several proposals to how to generate a MAC address in order to provide location privacy. But we don't know. I mean, we didn't study which one is good for Ipwave. So we should study about those proposals. Yeah. So also now we have MAC address randomization, MAC address change, and pseudonym change. But those are from the perspective of our working group IP version 6. Those are not enough. For example, still IP version 6 protocol, they contain some identifier information that can be used by attacker to track the vehicle. For example, IPsec or IKE, TLS protocol, they have some informations. So I suppose we need to have some clear text about those security and privacy issues, and we should put those issues in our working group documentation. And today I didn't much present about V2V and V2I scenario or consideration, but I believe there are also very security problems there. Thank you.
Any questions?
Hi, Min-Hung. Turn to the page page about the assumption.
maybe page 5. Yeah, I think the assumption should be made more general than this, because that, as I said before, that we are talking about now the security privacy in Ipwave, but not the security privacy in 802.11 OCP especially. So and the charter defined that we can use some like 802.11 and some other WiMAX, Wi-Fi, or any other technicals. So we should make the scope more general.
Well, I think you are right in the sense that the informational document mentions other potential link layers. So I think it's good to even though OCV is, I mean, for this informational part, the informational documents, OCV will be the main link layer that we consider. I think it's good to consider also other potential options.
Yeah, I think the 802.11 is the main consider, but I don't think it is the only consideration, because that when you use other link layer mechanisms, and the security and the privacy may be different.
Sure, but
I mean, actually, there are other link layer to be supported in vehicular communication in our working group, like LTE and LP1. Okay, but in this slide, I didn't prepare that case, but if we have separate documentation about security and privacy, we are going to fully consider about those all link layer protocol. Okay.
Okay, and just to, I mean, there are two parts. One is on the main deliverable, the standard track document, that is OCV. That's for sure. So, and there should be privacy and security considerations there. So that part of information here may be considered for that standard track document. And then for the informational document, yes, we should consider other potential technologies as well.
Thank you.
Good afternoon. This document is a neighbor discovery to support direct communication.
Please stand in the box. There's a camera there.
Okay.
Ah.
Oh, okay. I'm Zhiwei Yan from Scenic. And actually, I here define the functions of the neighbor discovery in ITS to two aspects. The first is to discover the neighbor vehicle and the neighbor service. It is a up layer function. And the second is to learn the link layer address all the other geo information of the selected neighbor vehicle to establish the communication. It is a lower layer function. And I also assume here that the vehicle should have a temporary name. This name should be related to the location. And the vehicle should also have at least a global IP address. And this IP address should be more stable. I show a figure here is about the network architecture, about the name and address management in the ITS. I'm not sure, but maybe this is out of scope of my draft, but I think this problem should be discussed in this working group because it is related to the communication and the management of the resources. And in the up layer, it's a router, and it advertises or manages the IP prefix, and the vehicle should configure the IP address based on this prefix. And the lower layer is ISU. It direct communicate with the vehicle, and it also advertises some name prefix for the vehicle to configure a name. Based on this assumption, and I here use the multicast DNS for the two functions. Because the multicast DNS is suitable for this infrastructure-less environment, and it can also be used to discover the named service and named vehicle. And I consider two cases. The first is the ad hoc based mode. And in this case, different modes can be used in different scenarios, because I think the multicast DNS suppose many cases. For example, in order to locate the specific service, the one-shot multicast DNS query can be used. And in order to locate the nearby vehicles which are moving, the continuous multicast DNS query can be used. They also have some other communication modes. The second is the ISU based. In this case, the vehicles may have direct connection with the ISU, and the ISU is acts as the local DNS server, and it may maintains the registered vehicles and services in its scope. Then the vehicle can send the unicast queries to the port 5353, or just use the legacy unicast DNS message to ask the nearby vehicle and the service. And except these normal cases, we can also make use of some other functions in the MDNS to support the neighbor discovery. For example, when a vehicle starts up, firstly enters into the ITS network, it can probe and announce its existence and the service. When the vehicle will arrive at its destination, or it will shut down some equipment, it can announce the service is suspending and is in existence. But we should consider how to support other lower layer information, like the link layer address and the geo information. We have two choices. And the first choice is to extend the MDNS resource record to piggyback this information. And another choice is to use the NDP protocol or other schemes. I also listed some security considerations in this scheme, and for example, the DNS traffic reduction and flooding avoidance. Actually, they also considered by the MDNS, like the DNS message origination check and the tampering avoidance. So that's all. Thank you.
Any questions?
Yiben Shen from Senjinguan University. So yeah, it's good to use MDNS for service discovery, but did you consider the mobility, because we are now in a fast-moving environment. So as I know, the continuously query in MDNS, like the querying is quite, the interval is quite long.
Yes, mobility will be will affect the performance of the MDNS, because the DNS response reply message will be affected. We will consider what it can be figured out. Yeah.
Okay. Yeah. Which is possible that when you discover that service, but the service is out of our scope. Yeah, we cannot use it. Right. Okay. Thank you.
Okay, then it looks like we're going to wrap up. Oh, here we go. We only have 2 minutes left, so you're going to have to hit your high points.
Okay. I will be very fast. So this slide is also talking about security and privacy consideration for IP over 802.11p. So it divided into two problems. I think the first one is the security problem. I think some speakers earlier also mentioned that. As AD suggests, I think those problems maybe come up into some combined unified problem statement document. And here we list the problem and some requirements based on that. The first problem is that, as we all know, the 802.11 OCP doesn't have a layer 2 authentication mechanism, and it doesn't provide any security mechanism in the layer 2. So that will be very huge challenge for the IPv work we are trying to do here. So here we have a requirement that similar to non-IP safety critical communications, the IPv6 over 11 OCB packets also must contain a certificate, including at least the public key of the sender, that will allow the receiver to authenticate the packet and guarantees legitimacy. So that's a basic requirement. And here is a very simple proposal. I don't think this will go into any spec in this working group, because I think the solution will need a whole architecture. But in this working group, we don't have such architecture as a context. But here is very simple example here. There is a backend server which can provide the certificate for the vehicles. And we can also use our IPv6 messages to transfer those certificates. And there is additional requirement about the certificates. First one is we need to consider the changing of the certificate, because for privacy reasons, we may change the MAC address of the vehicle. Then the certificate may also need to be changed. Another thing is that the guidelines to use the certificate, we can follow or refer to IEEE 1609. And the problem number 2, privacy. I think earlier speakers also mentioned that, how to protect the user privacy. So we also put a requirement here. It's important that the sniffer, at least along the roadside, cannot be easily able to identify the privacy information of the automobiles passing by. So that's very straightforward. Solution is to randomize the MAC address and also the IP address. So here is very simple example. We can set the bit local global of the MAC address to local administrated, and also we use the unicast address. Then we can randomize the number for the last 46 bits. Okay, so that's the contents of the draft. So I think the security and privacy consideration should come into the problems in draft. So we will consider that in the next version.
So I would encourage you to start a thread on the mail list that says that points to your draft and says you'd like to see this put into the document, and then we'll see where the group goes with that discussion. We are out of time, so I want to make sure that you get to your next sessions on time. Thank you so much. Well, where's the blue sheets?
The blue sheets.
I think we're going to have a document. Thank you for all your legwork, making the agenda and getting stuff posted.
Okay. I mean, there's
No blue sheets are coming forward.